All right, then I guess we can start. So first of all, welcome to our session, Implementing an Event Sourcing Strategy on Azure. Couple of words about the idea for this talk. Then we will introduce ourselves. Back to the times when I was working with the warehouse system, I was thinking what kind of architecture and infrastructure would be a good fit for us. And we decided to use Azure Cosmos DB, and Eldert was a great help of figuring out many different details. And at some point, we came to this scenario with event sourcing, and we decided to create a session around it because it was very interesting for us, and we wanted to share with everyone else. So about me, my name is Olena Borzenko. I based in Germany, in Berlin, and I work in a company called the Adecco Group. And today I'm going to share the stage, virtual stage, with my friend and mentor, Eldert Grootenboer.
Thank you. Yeah, so I'm Eldert Grootenboer. I come from the Netherlands, where I live in Rotterdam. I work with a company called Motion 10, and we focus on everything Microsoft, basically. Myself, I'm a technology lead. I focus mostly on Azure and integration. I'm also an Azure MVP, so I love doing these kind of talks. I do a lot of writing, blogging, basically anything I can do with the community, I love to do. And as you can see, our Twitter handles are here, so if you have any questions, any comments, please let us know. And with that, let's go to what is actually event sourcing. And I know there's at this conference, I think most people will actually know what is event sourcing. But I was looking at Twitter yesterday to the tweets of event sourcing live. And I noticed there's still some people out there that don't quite understand what event sourcing is. So I want to do a very quick introduction. Okay, what's event sourcing? And then we are going to jump into, okay, how do we do this with Azure and actually go to some demos and other nice things like that. But before we do that, event sourcing is really a way to basically use events to create a state of an object, of an entity. So let's say our entity is an order. So our order would first be created. Then we would have another event that we added 2 shirts. We would have another event that we added 4 hats. We have another event that some shipping info was added. And now if we look at these events, like we played back these events, we'll get an order with 2 shirts, 4 hats, and some shipping info. So we don't update an entity in a database or something like that. No, instead we have all the events together. And by looking at those events, we can basically calculate the state of our entity. So why should we use event sourcing then? Well, first of all, I think most people will have created some CRUD application at some point. So we create something, then we read it back. At some point, we are going to update it. We are going to delete it. However, CRUD is awesome if you are working like with, well, I would say high throughput, but not extreme high throughput. Because once you start talking about extremely high throughput, like millions of producers and consumers all work on the same objects, you're going to run into some issues. And the one that we see most is where data is being locked. So I'm going to create an object, I'm going to update it, and as I'm updating it, I want to lock that data because I want to make sure that the thing that I'm updating will be there before someone else updates the same order in this case. But because we are locking this data, that means that other producers or consumers cannot work with the data at that moment. So what we are going to run into with, if you are using many different, like very high throughput, we are going to see that this actually is going to deadlock our objects. So this means that the CRUD is not really easily scalable. So event sourcing helps on this, because instead of actually locking the data, we are just going to push in events. And that way we can actually scale it very high, because all we do is just write to that data store. We're not updating anything, we are just writing to the data store. And then our consumers are just going to get, okay, this is the latest status of all the events. And then they can calculate their current status. So this is why event sourcing is so important, that we can very easily scale up, unlike with CRUD. Also with CRUD, concurrency is quite difficult, as I just mentioned, because concurrency means that we are having all these different entities working with all these different producers and consumers working with our entity. And because they're all working with this together, it becomes hard to actually know, okay, what is the right status to update? Let's say consumer A wants to, or producer A wants to update our object, it wants to add something, but also producer B wants to do the same. Are we going to first wait for producer A and then go back to the producer B, or is producer B going to work on the same object, or how are we going to do this? Once again, this is where event sourcing comes in, because it just, like I said, it just pushes in events, And so all the different producers can just push in events and it will just calculate its state in the end. Another downside about CRUD is that there's no history. We cannot really see what happened to our object unless we create our own like history table or something like that. But out of the box, CRUD doesn't really have any history with it. So we actually have to build it ourselves. So this is where the event sourcing pattern comes in, because event sourcing, it doesn't update its objects, it only does inserts. You only insert into your data store, and as long as your data store can actually handle all those inserts, then you will be fine. So this is really for those write-heavy workloads, where they have many different producers all writing to the same objects. This is where the event sourcing pattern really shines. Because inserts are just much more efficient. Most data stores can handle inserts very easily. It's updates where it becomes quite hard because of concurrency, because of the locking state, because of needing to find out, okay, am I always in the right state? Inserts are much more efficient, much easier, because I can just do as many inserts as I want and it will just work. And of course, we have a built-in auto lockers here as well, because actually I'm going to see that all the different events are just what happened to my order or my other entity. So I can just very easily look at my different events and say, okay, this is what happened. So first it was created, then we added something else, we added the shipping address, and all this is just there in the event store anyways. So let's have a look at how event sourcing works on Azure.
Actually, I wanted to remind you that every time we also talking about scalability. Can you tell us about event sourcing and scalability a bit?
Yes, of course I can, because event sourcing is really nice with scalability, because as long as I can have my data source scale up to handle those inserts, and we'll see in just a second which Azure service actually allow this, as long as my data store can scale up for inserts, I can scale out indefinitely. Because as long as I can do inserts, then everything is fine. I don't have to think about concurrency. I don't have to think about locking or anything like that. So as long as my data store will allow me to scale up, then I will be fine with event sourcing, because I can just keep on pushing this data in.
Awesome.
And so let's actually have a look at event sourcing on Azure and which services allow for this very high throughput, highly scalable operations. And Olena, you might want to tell us a little bit about Cosmos DB.
Yes, as I already said, in our case back then, we used Cosmos DB. First of all, we decided that we want to go with Cosmos DB, but then we realized that it could be a great fit for event sourcing strategy implementation. And there's a couple of reasons for this. First of all, it's a globally distributed database and it's massively scalable. That's exactly what Eldert mentioned before. And scalability for us is very important. And Cosmos DB, besides those two options, also have change feed, which is also event sourcing out of the box, basically. And later on, I'll give a bit more details on what is change feed actually is. And to the next.
Awesome. So yeah, so Cosmos DB is amazing event store because it can do that very high scalability. However, we also have to ingest those events. So we have to have some way to have all our different producers deliver their events and then push it into Cosmos DB at some point. Now, we are not going to expose our Cosmos DB directly to our producers because we want to have this decoupled. Our producers should not know about our event store. So instead, we are going to place event hubs in front of this. And event hubs is amazing because it can handle millions of events per second. It can scale, once again, very highly. And it's really meant for this kind of streaming data where I get all these events coming in. And for those that don't know Kafka, it's basically it's similar to that. It's not the same, but it's similar. So you have a stream of events that can come in. You can read those events. You can play over them. Like I can go back into the stream. I can move forward into the stream. And actually also has a Kafka-enabled endpoint. So if I have a Kafka application, all I need to do is just change my connection string to my event hub connection string, and it will just work. So this is really nice if you're already in a Kafka, but you want to have a more PaaS version on this. And so event hubs really allows us to have a high ingestion of events and process them in a way. And once they're in event hubs, then we are going to use functions, and Olena is going to talk a bit more about those.
Yeah, functions, well, first of all, we wanted to develop quickly, of course, and we wanted to have independent implementation, independent processes. So Azure Functions allow us to concentrate on business logic, have small modules which we can independently scale, deploy, and use. And it's also, because it's part of Azure, Azure feature, it's a great fit for our basically demo for our technologies.
So exactly. And with that, so we are now seeing, okay, these are the three main pillars that we are going to build our solution on. So let's actually have a look at our demo. And in this demo, we are going to build that warehouse system that we were talking about before. Of course, it's a demo, so we are not going to have everything around there about that warehouse, but we are going to show you how we are going to create orders, how we are going to store them, and how we are going to work with these. And for this, I'm going to use a Kafka application because, like I just said, our event hubs can actually work with a Kafka-enabled endpoint. So what I want to show you is that I have an application that's going to create those orders, but it's a Kafka-enabled endpoint. So my application is going to create Kafka messages, events, and going to push them into event hubs. Event hubs is then our ingestion store. So we're going to read all the data. We are going to get it in there or get all these events. And they use a function that will be triggered from those events. And this function will then grab those events. It will make sure that I can do all my check marking and stuff like that. It's going to get those events. It's going to then store them into Cosmos DB. Let's have a look at this. So first of all, I'm going over here to my application. So I have this worker over here, my Kafka producer, and this is just going to create some orders. So if I have a look at what's happening here, so we have a producer. So this is our Kafka producer. As you can see, it's in the Confluent Kafka library. So this is just a Kafka producer that's going to create some events. And I'm going to what I'm going to do is connect to this connection string over here. And this connection string is actually my event hubs connection string. So as you can see, I don't really have to do anything except just change my connection string to my event hubs endpoint, and it will then work. So what I'm going to do, I'm going to create 1,000 different tasks, and I'm going to basically just create all these different orders. So this is just going to run 1,000 different orders and just going to create those. Now, the creation of the orders is nothing too special. By the way, all our code is on GitHub. So if you want to have a look at the code a bit better, you can definitely do that. It's on GitHub. It's open for everyone. I will share that later on. For now, I just want to quickly show you that we are going to produce some orders, and this is just random data. So we are going to create an order. We are going to look up some data about where it's going to be delivered. And then we are going to add some articles. So once again, randomly, like we do between 1 and 6 articles, just so we have some different kind of orders, which we can use later on. It's going to change statuses. So it's going to go to some different statuses. It's going to maybe update some articles, like depending on some random data. It might cancel some orders. It might start picking the orders. It might go out for delivery. At some point, it's actually delivered. And all this data will then come into our event store. So there will be different events for the creation, updating, cancellations, deliveries. These will all be different events that we then can later on use to actually calculate, okay, what is the status of a specific order? So let's run this, and while that is running, I'm going to my next part. So just going to check, okay, so things are running, messages are being sent, so it's now going to send those 1,000 orders. And while this is sending, let's have a look over here. So in my Azure environment, I have this event hubs. Actually, not this one. Let me grab it over here. So I have this event hub. And this event hub is just going to be that position where all the events are coming in. So just think of this as a big pipe where all the events are being pushed into. And like I said, I can then actually show you that we are getting those events. We are going to process them. And with event hubs, I can also, like I said, go back into time, go forward into time. It really allows me to just say, okay, which events do I want to get? Same as with Kafka. You can go back into the stream, you can go forward into the stream, all that kind of things. Now, like I said, we are going to use a function, and that function is then going to trigger whenever something comes into this event hub. It's going to trigger it, and it's going to process it. So let me show the code for the function. And of course, functions are very nice because they are serverless. They will just spin up when needed, spin down again when they're done. But what's also amazing about functions is they have these bindings. Out of the box, we have about 30, maybe 40 bindings at the moment. And one of those bindings is the event hubs binding. Now, what does this binding mean? A binding basically allows me to completely abstract away all the implementation logic. As you can see here, I have this event hub trigger. And that's all I need to know about event hubs. I just need to know I have this event hub trigger. I'm going to check, okay, which event hub am I going to listen to? I provide my connection string, and that's it. And then I get this event data, which is an array of events. And that's all I need to know about event hub. I don't need to know how I'm going to do my check marking. I don't need to know how I'm going to work my pointer, all that kind of things. That's all abstracted away from me. So using these bindings really allows me to work with this data in a very easy way. Now, of course, you don't have to use the bindings. For example, I'm going to work with Cosmos DB. My Cosmos DB, for Cosmos DB, there's also a binding. I could just use this Cosmos DB binding over here. But what if I want to have some more control? So for that, I can actually just still use the SDK, of course. So as I'm showing here, like I'm using the SDK over here to actually connect to Cosmos DB. Just to show you different options that I don't need to use the bindings. I can also just use the SDKs and things like that. So in this case, I'm adding some additional control over this, which I would not have with my binding. For example, I want to ignore null values. Now, what I'm going to do then, so this is triggered every time there's an event in there. It's going to trigger, it's going to grab all those events from there. It's giving me an array, and I can then use this array with the different events. So in this case, I'm going to create my database if it doesn't exist, and then I'm going to look through these events. So in this case, I'm not going to do that much with my event. I'm just going to store it in my event store, in this case, Cosmos DB. So in this case, I'm just going to upsert an item. So whenever I get a new event, I'm just going to insert in my Cosmos DB. And let's have a look what this looks like in my Cosmos DB then. So if I go over here to this one, and then let's check. Actually, so just to show you, my function is already running. So the code I just showed you, I already deployed, of course. So this is already running in Azure. So it's just as soon as I hit that Kafka producer, it started running. And as you can see, it's now processing some events. As you can see, it just processed this. Okay, so I'm not sure what's happening here. Let me refresh once more. Okay, so my portal doesn't want to show me, but what you will normally see is that there's a lot of data coming through here. Now, over here, I have my Cosmos DB. And in this Cosmos DB, you already see some other stuff that we will use later on. In this case, it's this orders container that I'm going to work with. And this is just my event store. So these are all the events that I'm just getting from my event hubs, pushing into my Cosmos DB. Let's have a look at a few of these events. So let's just grab a random one. So in this case, I have this event over here. Like I said, there's an order status, there's a hub. So it tells me about, okay, which warehouse is this for? It tells me a bit of information about my customer. So where do they live? Things like that. I have some articles in there. So the order actually. And so this is just my event saying, okay, this is what I produced. So let me grab something else. Let me find something that's not requested, but some different status. So let's go back to more back. Of course, I created a lot of requested ones, so I'm not sure if I can find one easily, but I will try a little bit more, but otherwise we're just going to continue. Well, as you can see, there's just a lot of different events in here that are just coming through. So I cannot quickly find something, for example, that's been picked or something like that. Like I said, I just produced a lot of events, so they will be in here, just a bit hard to find at the moment. So anyways, so let's actually just go and see what we can now do. Because we now have our events in here, so what we can now do is actually start processing these events. And for that, I'm going to hand it over to Olena. So Olena is going to talk a bit more about materialized views.
Yes, so we already saw how we can basically write our data to Cosmos DB. Now how we can consume this data, how we can fetch, what we can do, and so on. So we go in with the materialized view approach. We want to extract our data, not extract our data, but at the moment when we write our data to Cosmos DB, we want to aggregate it or create some summary, basically materialized views, and write it back to Cosmos DB. One second. So why what's the purpose of creating a materialized view? Ideally, not ideally, but in a normal world with relational databases, what I will do, I'll just create a query and I will call this query every time when I need to fetch this data. With the Cosmos DB, that's not a case, because every time if we will have a complicated queries, our U consumption will grow significantly. So for this, to have more efficient querying, we will create those pre-popularized views. And every time when there is a change going to happen or some data are going to be written in Cosmos DB, we will react on those changes. And for this, we will use Cosmos DB change feed. A bit of details on how the change feed actually works and what is how the materialized view looks. When we have our application and we write some data, as you can see on the screen, it's some order information, user information, and create date, and there could be much more. We wrote this data, and the change feed, which is listening to this, not listening for this container, going to save all the updates, everything what is happening in our container, in our Cosmos DB. Every update to our order record or every new insert going to be saved as a separate document in change feed. So after this, we can basically consume this information. We can consume these events. And there is these 3 ways how to basically get this data from change feed. The first one is the most complicated. It's a pool model. Basically, when we will extracting from change feed all the events, all the documents, and basically we decide what to do next. We can transfer this data in another data storage, another Cosmos DB, maybe cold storage. But in this case, when we pull in the data, when we pull in those events, we have to take care of everything: how to deploy a host application, how to the exception handling, which partition we want to listen. Basically, everything is on us. And this is very complicated approach, but for one-time data transfer is the best one, I think, in my opinion. And another way is to use change feed processor, basically implement change feed processor, which is abstract on top of change feed. And this will allow us to subscribe on a specific container. And when the changes are going to happen there, either it's insert or update of our data, those events going to be pushed to change feed processor. And then we can react, transform our data, create materialized view, do whatever we want, save it back. And basically, that's much easier way than the previous one. Because we don't need to, basically the SDK is going to do the whole work for us for the Cosmos DB. We just need to specify connection string and which container we're going to listen. And of course, our business logic. And the last one is Azure Functions. Very similar to the change feed processor, but it's like even higher abstraction. Everything is handled by Azure. What we have to do is to write our business logic, provide connection string, and provide the container name which we want to listen. So basically, this is like 3 known ways how to consume the data from change feed. And once we did it, when we consume the data, we will create different materialized views.
So what you just said, like you are going to create different materialized views, that sounds like you're duplicating your data. Now, when I was in school, like I was always told, like, you don't duplicate your data, you normalize everything, you can never have duplication. Now, this seems like you are going to go the completely other way. So can you elaborate a bit on this?
Yes. I'm still wondering what kind of school you visited, that you learned it at school. But yes, that's exactly what we're going to do. We're going to duplicate our data. Basically, as I said before, for Cosmos DB will work a bit in a different way than any other relational database, regular databases. Cosmos DB uses partition strategy. So basically, they for horizontal scaling, they have physical partitions, which are physical servers when they store data, store all the documents, containers, and everything. And every physical partition, first of all, they can be distributed all over the world, but also there is no guarantee that our logical partitions, which are actually contains our documents, the group of our documents, will be all of the containers from the same database, that they all will be stored on the same physical partition. They can be distributed. There is guarantee that the documents from the same container always will be together, but there is no guarantee that the whole database will be stored in one place. Of course, it's in most of the cases it will be like this, but if your database is huge, then it might be distributed. And it means that every time when we will have queries, we will have to access different servers. So it will be quite expensive for us. To avoid this, to make it more efficient, first of all, faster and cheaper, and save on RU consumption, we will kind of calculate our queries and save those snapshots. And then we can just fetch it. And if everything is done right, this could be very, very cheap operation.
Thank you. Very clear explanation.
You're welcome. So we are going to a demo part now. So we already saw how we can write all these events to Cosmos DB, and what we will do now, as I already mentioned, we can subscribe to a specific container, and every time there's change can happen, we will react on it, and with Azure function, and we will create materialized view and write this data back to Cosmos DB. We will have two different materialized views, one for the customer overview, another one for the hub overview, for the warehouse overview. And we will see basically that this data will be available for our clients in our Cosmos DB and easily accessible in the future. So I will now switch to my code. I hope the size of the code is okay. Otherwise, please drop somewhere a message in the comments. But anyway, so that's how it looked like. Change feed trigger. That's the name of my function. As already mentioned before, this is Azure function, and the only thing I have to do is to specify the collection name and the database, and of course connection string. In this case, we have Cosmos DB trigger. So when some change is going to happen in our container, we will receive an input object. It's a read-only list of documents. And then we will be able to basically manipulate with this data, do whatever we want, and write it back, in our case, to Cosmos DB. I'm going to use Cosmos Client. I'm going to connect to my database directly to write my data, but there is another way using Cosmos DB binding, which is output binding. We can also write this data when we will finish. For example, we will transform our data. We will create materialized views, and in the end, when we decided that we are already done, we can save to another collection of documents, which will be like connected to a second binding, save our information, and when Azure function will finish execution, it will be automatically saved to Azure Cosmos DB, and we will have no need to do any manual save operations or pushing data to the Cosmos client. But just for the demo purposes, I decided to use also trigger and Cosmos client just to show that it's also possible and what's the difference. So, as I said, we will have two different materialized views. One is for customer, another for warehouse. The repository itself, more or less the same. The only difference was repositories. I created this to operate with my documents, to write these documents to Cosmos DB. So the only difference is the container name. So for the customers, it will be customers overview. For the warehouse, it will be hub monitoring. And I also providing the partition key, of course. And the base repository is basically how we're going to work with our documents, how we're going to access them, write documents, and update documents. I have get document, which is, in my case, going to be point read. So I know that ID of my document will be unique, the same as partition key, which I'm using for this document. So I will access my container, and using read item async, providing ID of the document and partition key, I will get this document. And in this case, in my case, it will always be only one request unit because I will know what file exactly I need to access. For the creation and updating document, they are quite similar. The only difference is the actually method name. Of course, in the real world, they're going to be much more logic. But what I'm doing here, I'm creating a partition key. I'm providing it ahead. And as we saw before, when I'm creating a container, I'm providing the property name for my partition key. But here I'm doing this again. I'm specifying it explicitly just to make a small performance for the SDK, basically. If you would not create the partition key here, it's not mandatory. SDK will extract it under the hood, but it's just to have a little improvement. And another one, which I also quite like, is enable content response on write set to false, because I'm not interested to know what exactly was written in Cosmos DB. I just need to know that my operation was successful. And basically, that's all for the repository functionality. What is happening next, that we are just receiving our documents and we are checking, okay, if there's any, and if it's not now, writing some log information, and then iterating through those documents, deserializing to the order object, we're going to create those two overviews. If we will have a look here, the logic is the same for the customer overview and hub overview, more or less. I'm just trying to get materialized view and understand if I already have it in database or not. And if I have it, then I will just update it with the new information. If I don't have it, then I will just create a new one. For the warehouse overview, because I want to see this kind of summary information on my dashboards, on my screens in the warehouse, I want to see a number of orders for today. To make it easier to query and cheaper to query for me, I decided to use a synthetic partition key, which is basically hub ID and date. This will allow us to have a unique document for every day for every warehouse. And when we created materialized view, we saved it here on this stage, either created or updated. And that's basically all what we need to in our Azure function to create different materialized views for our data, which is written in the Cosmos DB. If you will go to Azure portal, and we will have a look how the data actually looks like after it was after materialized views were created. First of all, this is Azure function which is already published there, and I just wanted to show that we saw that okay, the some data that it was triggered. Yeah, here we see it. And if we go to our Cosmos DB, we can see that we already have a few containers here, as I showed before, customer overview and hub monitoring. So if we check items, as I said before, we're using hub ID, warehouse ID, and today's date. So for every day, we're going to have a unique document with all the numbers, order numbers, and count amount basically of those orders which we received in this warehouse. And basically my function was already published, of course, when Eldert was running his part of demo, so I already have the results. And for the customer overview, here we have as well, we have unique document, as I said already, unique document for every customer. And here we will see the information for the basically order summary for the customer. So what is happening, what is the status, what is the articles, and basically everything what we need. So anytime and any place of the application when we want to access this data, it's already pre-calculated. So it means that no queries, no cross-partition queries, no aggregations, summary, real-time, whatever, nothing will happen. We will just access one file, deserialize it, and send it back to the client. So that's basically the great point, I would say, in using this approach in general, and not just Cosmos DB, but approach of materialized views. And going back to our demo, not our presentation. Oh, sorry. Yes. No, my demo don't want to leave. Come on. Okay. So we already saw how we wrote this data, how we read this data, how we can read this data, how we can basically aggregate it. And just to summarize everything, we want to give a couple of key takeaways. And first of all, Cosmos DB is a great central and on the persistent data store. Not only because it's just documents which we can insert without any updating, but also a change feed, which is event sourcing out of the box, allow us to have the history of all our changes, all our documents for the whole time, and basically access anytime when we want it.
Yeah, and so of course, when you're working with like this very heavy write loads, definitely have a look at event sourcing. I'm not going to say that event sourcing is the one solution to every problem, because as always, you really have to think about what am I trying to approach here? What am I trying to do? But definitely do have a look at event sourcing when you are in these kind of scenarios where you have those heavy write loads.
And prepare materialized views for various consumers. As we saw, it's first of all quite easy to do. We have Azure Functions, small pieces, small modules of our business logic. They are independent, so every time when the client needs new materialized view or we have new client, new consumer, it's very easy to basically extend our application. And the great benefit of it also that we have single source of truth. All our materialized views are created from the same container, from the same events and data. And if there is some problems, or maybe we want to have, I don't know, smoke testing, doesn't matter, we can access those events anytime and replay it from the very beginning or from the specific point in time.
And of course, have a look definitely at Azure for these kind of solutions. When you're working with event sourcing, you want to have something that's highly scalable, that can handle all those different events, and Azure is perfect for this. You have seen today how Cosmos DB is a perfect event store to actually store all these different events, to get all that ingestion. Event Hubs allows you to actually get all those events in at the same time. And of course, functions are amazing because they are serverless. You only pay for what you use. And you can just spin them up as events are coming in. And as long as there are no events coming in, you don't pay anything. When there are new events, it will spin up, it will scale up. And this is really what you need in this kind of scenarios. So definitely have a look at the Azure ecosystem to actually build these solutions in an easy way, but with all the power that's behind there.
Yeah, but also don't go crazy with Azure. It's all about implementation. Tools are great, but sometimes we have to also do something on our own, right?
Definitely.
Yeah. So thanks a lot for the attention. Thanks a lot for being with us today on our session. Once again, my name is Olena Borzenko. You can find me on Twitter, on LinkedIn. If you have any questions or comments, I'll be happy to chat and end it.
Yeah, so indeed, thank you everyone, first of all, for being here, of course. And also thank you, Olena, for being an amazing co-speaker. I really enjoy this, as we always do. Yeah, so if there's any questions, please put them into the chat, into the comments. Or later on, you can also, like Olena already mentioned, you can always contact us. We are happy to answer with any questions that you might have.